Hello. So we're going to start talking more factorizing using algebra tiles. Before we do, and you might feel a little bit this way too, we haven't been in school for a while. Why didn't the skeleton kid want to go to school? Okay, so let's talk about using algebra tiles to factorize more. This time we've got x squared plus 4x. In the last video, we left off with the last couple examples. We ended up with squares. So we're going to start talking about this technique in algebra called completing the square, which the name gives it away. The idea is we want to make squares. And we'll see why this is useful. It's going to be useful in all sorts of applications in algebra across the next however many years you're doing math in school. You're going to use this technique called completing the square. So I've got x squared plus 4x, and I've got my x squared and my 4x is over here, and we want to make a square. Right? Anytime we realize or we're told we need to do this, we want to make a square. So how can I make a square with these? Well, we can start trying. In order to make a square, both sides need to be the same, right? So if I do this, this side is x squared plus 2. So that side is x squared, I need plus 2. So I need to rotate these then, don't I? And if I do that, okay, at least both sides are the same. That's x squared plus 2, x squared plus 2. But we haven't made a square, and we have no other pieces. It looks like it's going to be impossible to make a square with what we've got. And as a matter of fact, it is going to be impossible to make a square. But there's a nice little technique, and we do this in math quite a lot. So what's wrong? We're missing 4, aren't we? We need 4 ones to go down here because that's a 2 there and that's a 2 there. 2 times 2 is 4. We need 4 ones. Now, can we just grab 4 ones? And then stick them in there to make a square? Well, if we just grab 4 ones, we don't have x squared plus 4x anymore. Now we have x squared plus 4x plus 4, which is not the same thing. If I put a number in for x, and work out x squared plus 4x, and then put that number in x squared plus 4x plus 4, they're not the same thing. Here is a nice handy little trick. So I need to add 4 ones, don't I? Well, look at this. What if I add 4 ones, but I also add 4 negative ones? Right? I mean, what happens? 1 plus negative 1 is 0, isn't it? It's like it's not there. 1 plus negative 1 is 0. That makes sense? So, if I add 4 ones and I add 4 minus ones, this is still the same thing, isn't it? Because this is x squared plus 4x plus 4 minus 4 plus 4 minus 4 is 0. So this whole thing I have here, this big picture here, this whole thing is the same as this. It's still x squared plus 4x if I simplify it. Now this is the key. So can I make my square now? Yes, I can. There's my square. Okay, so my square is, that side is x, that side is 2, that side is x, that side is 2. So my square is x plus 2 squared, right? Again, that's what squared means we use the squared sign. So that's x, why do I keep getting this straight line here? So that's x plus 2 squared. Now, we're not done, are we? Because we still have these 4 minus ones over here. So we have to account for them. So it's x squared plus 2 squared. That's my square, but I also have minus 4. So we've ended up with a square. We've had a little bit extras. That's okay. The key is we need to get a square. All right. The key in this technique is we might have extras added on. Here in the case I have minus 4. But the important thing is I have a square. My square is x plus 2 squared minus 4. Now these two expressions are exactly equivalent. X squared plus 4x equals this. They are the same. And to check it, we could expand the brackets. Okay, if we were to expand the brackets, x plus 2 squared is x squared plus 2x plus 2x plus 4 minus 4. And if I tidy that up, I end up with x squared plus 4x. So it is equivalent. It's just another way of writing it. So when we complete the square, we're not coming up with something new. We're just coming up with a different way of writing it that has a square in it. And we're going to see why in this module, and then in module 7 next year when we do our graphing, and then all sorts of, in the next, I think it's module 9 or 10 after that when we do solving equations, we're going to see lots of reasons why this can be very useful. So we'll look at another example here in just a second. Let's tidy this up and then look at another example. Okay, here we go. X squared plus 6x. I want to complete the square. I want to make a square. So I've got my x squared. I've got my 6x's. Again, we want to make a square. Remember, for a square, both sides have to be the same length. So again, I want you, as we do these examples, think about what's going on. Ultimately, we're not going to use the algebra tiles anymore. We're just going to do this with the algebra. The algebra tiles help us see what's going on. I've got 6x's. Pretty much makes sense. I'm going to have to put half of them there and half of them here, aren't I? Right? In order to have a square, both sides need to be the same length. And that's x, and that's x. And I've got 6x's. That makes sense. I'm going to put 3 of them there and 3 of them there. Now I've got a big gap in order to complete the square. That's what we call this completing the square. We don't have a square. We're going to make a square. So how many pieces do I need there to complete the square? I need 9, don't I? So I can bring 1 down. I can use my copy. 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 ones that can go in there. But I can't just add 9 ones. Because x squared plus 6x plus 9 is not the same thing as x squared plus 6x. So if I add 9 positive ones, what do I need? I need 9 negative ones. Okay? Because each one of these cancels with each one of these. So really, minus 9 plus 9 is 0. So my picture here is the same thing. So to make my square, right, I need to fill my 1's in. Okay? So to complete my square, I need to fill my 1's in. I now have a square. Don't forget about these over here. So what is my square? We need to write this out algebraically. Well, this is x, this side, and that's plus 3. This side is x plus 3. Again, I'm making a square, so both sides need to be the same. So this is x plus 3 squared, right? That's the square over there on the left. And then I have minus 9. We'll just ignore this. It's very fiddly writing on the web pages here. So x plus 3 squared minus 9 is the same thing as x squared plus 6x, but I've written it using a square. So think about how we're doing this. Again, the object is going to be, we're going to get so good at these, we don't need the picture anymore. We're just going to be able to do this algebraically. So let's tidy this up, and we will try another example. Okay, here we go. X squared minus 4x, I want to complete the square. So I've got my pieces, right? So again, it should be obvious. I'm going to have to put 2 of them there and 2 of them there because I'm making a square. So it has to be the same. Notice what's happening. Whatever my number here is, right, half of them, half of them. Now, I don't have everything I need, do I? I have a gap here. So the question is, I need some 1s. The question is, do I need positive 1s or do I need negative 1s to fill in there? Okay, well, think about what we've got so far. That's x, that's minus 2, that's x, that's minus 2. So if I fill in the gap, if I fill in this gap right here, it's minus 2 times minus 2, that's a positive 4 in there. So I need 4 positives to fill in this gap. Because minus 2 times minus 2. I can't just put 4 1s in there. I need, if I put 4 positive 1s, I also need 4 minus 1s. Again, think about what's happening. So now I have my square, right? All the pieces on the board now, the square plus these 4 extras are the same thing as x squared minus 4x. So if I actually write it out, if you're told to complete the square, right? If I write it out, I have x minus 2 squared minus 4. That's what I get. And again, all right, we're never going to ask you to draw a picture on a test. The idea of using these algebra tiles is so you can see what's happening when we talk about completing the square. So again, when we complete the square, it's not just a square we end up with. Sometimes we end up with some extras. But the key is we need a square. And why, again, that will be coming. We'll see why that's going to be useful to write it like this. But these are equivalent. X squared minus 4x is exactly the same as x minus 2 squared minus 4. So again, think about these. I'm going to leave you some. Again, I'd like you to play with these with the algebra tiles. Try to make squares. Play around with them. But while you're doing it, think about what's happening. Our ultimate aim is to do this without the pictures, to just know what's going to happen when we do these. So again, I'll be leaving you some questions to go ahead and try. Before we do, why didn't the skeleton kid want to go to school? And her heart wasn't in it. Okay, we will see you later.